morning and welcome to the first edition of Optimizing Rotational Equipment with Uncle Morgan. My name is Doug Johnson and I am a part of Morgan Advanced Materials Applications Engineering team. Morgan is the home of national brand carbon brushes, your father's brush supply. Today, I want to talk about bearings in AC motors. Did you know they're the second leading failure mode after overheating? You're probably thinking Uncle Morgan has gone off the deep end. Carbon brushes belong on DC motors, and what does that have to do with bearings? Patience you must have, my young Padawan. First, a little history. Relax, it won't kill you. One of the main advantages of the DC motor was the ease of speed control through simple electronics. Technology at the time could not afford AC motors the same precision speed control. As electronics developed, variable frequency drives, or VFDs, became more reliable. It is now just as easy to control the speed of an AC motor. These induction motors had an unforeseen consequence. The VFDs induce a voltage on the rotating armature. This voltage has no place to dissipate without a grounding system installed. The voltage is forced to the next low resistance path. This is the bearings. Over time, the discharging shaft currents lead to fluted and frosted bearings, eventually total bearing failure that often permanently damages the motor. Luckily, Morgan engineers have been studying the effects VFD drives have on AC motors since the late 70s. Modern motor control systems use sine wave voltage inputs that rapidly change the magnetic flux surrounding the motor shaft. This change in flux causes various voltages to be induced onto the shaft. The larger the motor, the larger the induced voltages. The type of VFD also makes a difference. Insulated bearings can be installed, but this does not correct the induced shaft currents. It only redirects the shaft current through a gearbox or other connected device. This can quickly lead to the failure of an even more expensive piece of equipment. That is why shaft grounding is so important. Enter the ever-useful carbon brush. Utilizing a low contact drop silver graphite brush, Morgan grounding kits are able to quickly dissipate any grounding currents induced by the VFD. Morgan makes an array of shaft grounding kits to ensure your motor never fails from damaged bearings. With Morgan systems installed, any induced shaft voltages are sure to have a low resistance path to ground. Harsh environments are no problem. The brush grade will be selected based on the application and environment. Contamination, low humidity, and high temperature applications are all viable candidates for Morgan grounding systems. Now we'll do a demonstration. Don't forget your safety gear. I'm going to power on the demo unit. The oscilloscope screen shows a graph of the instantaneous induced shaft voltage. Currently, there's no shaft grounding. It is displaying a peak-to-peak voltage of 17 volts, more than enough to destroy the bearings. Bearings are damaged from as little as 5 volts. Now, I'll connect the shaft grounding brush. You'll notice the induced voltage is dissipated to near zero, saving the bearing to roll another day. The simplicity of our grounding system is what makes it so great. It can be fit to any size shaft without taking the end belt or brake off, and requires no special paste be applied to the shaft prior to use. Typically, the kits are rigidly bolted to the motor by drilling and tapping 2 holes. The motor doesn't even need to move from its service location. There is also an optional 3M dual lock adhesive mounting system available for those hard-to-reach locations. These kits require no maintenance and last through many service cycles. Morgan Advanced Materials has been a trusted supplier of quality carbon products since 1890. Please contact our Greenville office at 800-395-7776 with any questions on grounding applications or for detailed installation instructions.